Hey guys, welcome back to my YouTube channel MedEduphilia. In today's video, we will be continuing from where we left. So we were exploring the chapter Some Basic Concepts of Chemistry, and particularly we were discussing about the mole concept. So let's start today's session with few more questions on mole concept. So starting a class with questions is always interesting, isn't it? As solving questions makes our brain more active and attentive. So let's get straight into the question. The question says calculate the number of ions, the number of oxygen atoms, and the total charge in 3 grams of CO3 minus, that is carbonate ion. So what is the mass, gram molecular mass of carbonate ion? CO3. So 12 for carbon, 1 carbon plus 3 into 16, which is the atomic mass of oxygen. So 12 plus 48 gives us 60 grams, which is the gram molecular mass of carbonate ion. So we know this question is from mole concept. So the first step is to find the number of moles. So clearly we know that 1 mole of any substance has a mass equal to the gram molecular mass. So 1 mole has mass of 60 grams. So how many moles is 3 grams? So on simple cross multiplication we find that it is 1 by 20 moles. So the given amount is nothing but 1 by 20 moles in the question. So for subdivision we have to find the number of ions. So we all know 1 mole has 6 into 6, that is Avogadro number, 6.022 into 10 power 23 ions. So how much does 1 by 20 moles contain? Simple, again by cross multiplication we get 1 by 20 into 6.022 into 10 power 23 ions. We get approximately 3 into 10 power 22 ions. So here we focus on the method. Okay, so I'm approximating the answer. So this becomes our final answer. Next subdivision, we are required to find the number of atoms, oxygen atoms in 3 grams of carbonate ion. So now our job is easy because we've already found out the number of ions present in 3 grams. So we know 1 ion of carbonate ion has 3 oxygen atoms because it is CO3. So O3. So there are 3 oxygen atoms. So in 3 into 10 power 22 ions, that is in 3 grams of carbonate ion, there will be how many oxygen atoms? That is what we have to find. So again on simple cross multiplication we get 9 into 10 power 22 oxygen atoms. So this is our answer. Moving on to the third subdivision, which asks us to find the total charge in 3 grams of carbonate ion. Okay, so we know 1 ion, that is 1 carbonate ion, has 2 into 1.6 into 10 power minus 19 coulombs. So how did we get this number? Simple, carbonate ion, CO3 2 minus. So there is a negative 2, okay, minus 2 charge present in 1 ion. So this minus 2 indicates 2 electrons, 2 into 1 electron charge. So the charge of 1 electron is 1.6 into 10 power minus 19. So that's how we got the number 2 into 1.6 into 10 power minus 19 coulombs. So this is the charge present in 1 ion. So what do we need to find? We need to find the number of the total charge in 3 grams. That is 3 into 10 power 22 ions. So simple, again cross multiply, we get 3 into 10 power 22 into 2 into 1.6 into 10 power minus 19, which gives us 9.6 into 10 power 3 coulombs as the final answer. So the first step in such types of questions is to find the number of moles, and then the first subdivision asked us to find the number of ions, which we found using the Avogadro number, and then from the number of ions we found the number of oxygen atoms, and we found the number of the total charge present in that compound. Okay, so let's move on to the next question. Are you ready for the next question? So I recommend you to pause the video and try it out on your own, because all the questions that I'm giving you is of different types. They're not of the same type. Okay. So pause the video and give some time for your brain to think, to explore new types of questions. Okay, the next question goes as: elements A and B forms two compounds B2A3 and B2A. So there are two elements A and B forming two compounds. Okay, 0.05 moles of B2A3 weighs 9 grams and 0.1 mole of B2A weighs 10 grams. They have given us they have given us the compounds, okay, formed by A and B, and they have given us the weight of A and weight of those compounds. So we are required to find the atomic weights of A and B. So that is the question, and we are given with four options. So what do we have? We have two elements A and B. So these elements are forming two compounds B2A3 and B2A. So they have given that 0.5 mole of B2A3 weighs 9 grams. So there is number of moles given, and the given weight is also given. So by the simple direct formula of N, that is number of moles, we have N is equal to given mass by molecular mass. So applying that, 0.05 is equal to 9 by the molecular mass of this compound B2A3. So B2, so 2 times the atomic weight of B plus 3 times the atomic weight of A. So we write it as 2B plus 3A. Similarly, for the compound B2A, 0.1, they've given the number of mole is 0.1 is equal to 10 by 2 times B plus A. I hope you're getting. So let's assume, for the ease of our calculation, let's assume that this denominator B2A3, the molecular mass is X, and let's assume that the molecular mass of the compound B2A is Y. So this makes our solving easier. So on solving, we get X is equal to 9 by 0.05, which is equal to 180. When you solve, you get 180. Similarly, the right hand side, what do we get when we divide 10 by 0.1? Simple, we get Y as 100. So again, we know X is nothing but 2B plus 3A, which we got as 180. So the right hand side, again we got Y, which is 2B plus A, we got it as 100. So you can solve these two equations. We find that 2B is the term which is common in both the equations, isn't it? So you can simply subtract these two equations. So the 2B will get cancelled, and you are left with 2A. 3A minus A, 2A is equal to 80, which gives us A is equal to 40. So since we got the value of A, you can substitute this value of A in one of the equations to get the value of B as well. So we substitute A in this equation, 2B plus 40 is equal to 100, the smaller equation. So on solving, we get the value of B as 60 by 2, which is 30. So atomic mass of A is 40 and that of B is 30. So the correct option is C. Okay. So that's it. We have come to an end of mole concept. So I want you to practice more and more questions. This was just like a warm up for starting the session. I just wanted to give you two questions and start off. Okay, so now we move to the next concept, which is mass percentage. So simple, as the name suggests, mass percent, which means mass of that element by the total mass of the compound into 100. So let me give you a question. Calculate the mass percentage of carbon in ethanol. So first of all, we need to know what is ethanol. So ethanol is an alcohol because it's ending with OL. Okay, so eth means 2. So there are two carbons. So it is C2H5OH. So 2 times 12 plus 5 times 1 plus 16 plus 1, because it is C2H5OH. So what do we get? 24 plus 5 plus 17, which gives us 46. Easy, isn't it? This is why you should watch the first lecture carefully and practice more questions on how to find the molecular masses of different compounds. Okay, so now we have found out the molecular mass of the compound. So we have to find the mass percentage of carbon in ethanol. So mass percentage is equal to, so here the formula, mass of element is present in the numerator. Here this means it is the mass of the element in that compound. It does not mean gram atomic mass of that element. So remember, so we are finding the mass of the element present in that compound. So here there is 2 carbons. So because it is C2, so 2 times 12 by 46 mass of the entire compound into 100, because we have to find percentage. So we can cancel 2 and 46, because 2 times 23 is 46. So when you calculate, you get 52.17 percentage as the answer. Simple. So similarly, there is one more quantity known as the percentage composition. This is another topic. Next topic. Okay, so this percentage composition has the same formula as mass percentage. Okay, both the meaning of both is the same. So this percentage composition has many applications. First application is to find the minimum molecular mass. Second application is finding the number of molecules. So let's look at the first application through a question. Insulin contains 3.4 percentage sulfur. Find the minimum molecular mass of insulin. So this is the question. So they have given that insulin contains certain percentage of sulfur in it. So we have to find the minimum molecular mass of insulin. So for minimum, the word minimum tells us the number of sulfur atoms present in insulin is 1, because it is minimum. Okay, so same we can write the mass percentage formula, which is n into number of into the mass of the element, because we don't know how many atoms are present. Here it is given as minimum, so we take n is equal to 1. So this n into mass of element by total mass of compound into 100 is the general formula of mass percentage, because the numerator is not gram atomic mass of the element, it is the total mass of the element present in that compound. So keep that in your mind. So we can substitute n as 1, and mass percentage it is given as 3.4 into is equal 3.4 is equal to 1 into 32. Molecular mass of sulfur is 32, remember, by x, because we have to find the minimum molecular mass of insulin. So we have to find the total mass of the compound insulin. So x is the variable. So x is equal to 32 by 3.4, which gives us 941.176 U. So U is nothing but units. 941.176 units, or AMU. So there can be number of questions framed on the minimum molecular mass questions. So for all these types of questions, the only formula used here is the formula of mass percentage. Simple. So next we will move on to the next application, that is finding the number of molecules. Here I'll just give you a question. Okay. The question goes like Na2SO4 dot XH2O on heating gives Na2SO4. If the loss in mass after heating is 56%, find the number of water molecules. This is the question. So this is just a question. I will tell you the method of solving. You can solve it later. Okay. So we are heating the compound Na2SO4 dot XH2O. So this X, we do not know how many molecules of water is present in the compound. So due to heating, some amount of that XH2O molecules is being lost. So This loss in mass is due to the loss of H2O molecules, and that is given as 56%. So 56% is nothing but the mass percentage of the compound. So 56 is equal to X into 18, because H2O 2 times 1 plus 16 gives us 18. 18 is the molecular mass of water, by 2 into 23 plus 32 plus 4 times 16 Na2SO4. Okay, that is the mass of the total compound into 100. So from this equation you can find X, so that will give you the answer. So I am not solving here, you can solve and find out. So shall we solve another question on this application? Okay, the question goes like, the percentage loss in mass after heating a pure sample of 245 gram potassium chlorate, molecular mass is given, will be. So what should we find? We should find the percentage loss in mass, that is the mass percentage. So first we have to write the equation, potassium chlorate being heated. So potassium chlorate is nothing but KClO3. KClO3 is potassium chlorate. This on heating gives us KCl plus O2. O2 escapes into the air and causes a reduction in mass. Like how in the previous question there was water molecules escaping, which resulted in a reduction of mass. So we balance the equation. 2 KClO3 gives us 2 KCl plus 3 O2. Okay, so the percentage of mass is nothing but 96. So why 96? Because 3 times 2 into 16, because 3 molecules of oxygen molecule is escaping into the air. So 3 into 2 into 16 gives us 96. The percentage loss is nothing but 96 by the total mass of the compound given as 245. Okay, they have given a pure sample of 245 grams, so it's given in the question already. So 96 by 245 into 100 gives us 39.18%, which is option C. So now we shall move to the next topic, which is empirical formula. So we have heard of this term molecular formula. Now what is empirical formula? So empirical formula is nothing but the simplest whole number ratio of the various atoms present in the compound. Okay, molecular formula is shows us the exact number of different types of atoms present in the molecule of the compound. But empirical formula is the simplest ratio, that is when you cancel the common factor, whatever you get, that is the simplest ratio, and that becomes the empirical formula. For example, you take benzene C6H6. Okay, what is the molecular formula? It is C6H6. Empirical formula is CH, because the 6 we can cancel the common factor 6. Okay, so let me give you molecular formula and you tell me what is the empirical formula. First I give you diborane B2H6. So what is the empirical formula? BH3, isn't it? Next, Fe2O3. First, no common factor, so it remains as Fe2O3. Next, C6H12O6. What is C6H12O6? It is glucose. So empirical formula is CH2O. Next, Na2CO3. Is there any common factor? No, so we cannot cancel. So the empirical formula remains as Na2CO3, sodium carbonate. Okay, so here you notice that for Fe2O3 and Na2O3, there is no change in the empirical formula. It remains the same because there is no common factor. Okay, so here they will test you with few types of problems, which we will see one by one. The first problem: a compound of molecular mass 98.96 contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. What is the molecular formula of that compound? So this is the type of question that will be asked in your NEET exam. Okay, so they have given the molecular mass of the compound X and they have given that compound X contains different elements such as hydrogen, carbon, chlorine. So we have to find the molecular formula of that compound. Okay, so from the given data in the question, we can construct a table. Element, percentage, atomic mass, number of moles, molar ratio, and simplest whole number ratio. So this is the table that we can construct from the given data. So first element, they have given hydrogen. So hydrogen 4.07% is present. What is the atomic mass of hydrogen? 1. Now we have to find the number of moles. So here we have to consider the number of, that is the percentage, as mass, as the given mass. So we have to calculate the number of moles assuming that the percentage as mass. So 4.707 by 1, given mass by molecular mass gives us the number of moles, which gives us 4.07. Okay, so next element we have carbon. What is the percentage given? 24.27. What is the atomic mass of carbon? 12. So what is the number of moles of carbon? 24.27 by the atomic mass, which is 12, which gives us 2.02. Okay, next element, chlorine. What is the percentage given? 71.67. What is the atomic mass of chlorine? 35.5. So what is the number of moles? 71.67 by 35.5. Solve fast. What did you get? We get 2.02 again. Okay. So next column we have molar ratio. So what do we mean by molar ratio? So molar ratio is nothing but the number of moles divided by the smallest number of moles. Okay, understood? So 4.07 is the number of moles divided by, what is the smallest number of moles out of this three? H, C and Cl. It is 2.02. So we have to find the ratio by dividing 4.07 by 2.02, which gives us 2 approximately. Okay, next, find the molar ratio of carbon. Come on, 2.02 by the smallest out of all. Again 2.02 gives us 1. Similarly for chlorine also it is 1. So the simplest ratio, as you can see, is 2:1:1. So what does the simplest whole number ratio tell us? It tells us the empirical formula. So it is H, there's 2H. Okay, so it's first we always write carbon followed by hydrogen and then the other non-metals present. That's how we usually write the molecular formula and the empirical formula. So it is CH2Cl because the ratio is 1:2:1. Next, the empirical formula mass is what we need to calculate. So from CH2Cl we can find the empirical formula mass as 12 plus 2, because 2 times 1, 2, plus 35.5, which gives us 49.5. And they have also given us the molecular mass of that compound as 98.96. So from the empirical formula mass and molecular mass, we can find N. So we define N as the quantity as the ratio of molecular mass and empirical formula mass, which is 98.96 by 49.5. So what is N? You can easily calculate. N is equal to 2. So what does this N signify? So from this N we easily come to know that the molecular formula is N times the empirical formula. So 2 times CH2Cl. The molecular formula is C2H4Cl2. So this is the significance of N. So we have found out the molecular formula of that compound, which is C2H4Cl2. So you might find this method a little long. Okay, too much calculations involved, isn't it? Especially in that molar ratio part and finding the number of moles. Okay, so do I have any short trick? Yes, I do. So I will give you a question and then reveal the short trick. So the question is, in an organic compound, percentage of carbon is equal to 92.2% and the percentage of hydrogen is 7.7%. Same, they have given us the molecular mass of the compound, the molar mass of the molecular mass of the compound as 26. We need to find the molecular formula of the compound. Same format as the previous question. I have just given you the same format and I'm going to solve this question with the trick, with the short trick where you can save a lot of time. So here we just need to find the ratio of carbon to hydrogen. So they have given same thing we are doing. Simple, just divide, find the molar ratio. Okay, just 92.2 by 12 is to 7.7 by 1. So this gives us, we need to take the 12 to the other side. So 92.2 is to 7.7 into 12. So this gives us 92.2 is to 92.2 again. So what is the ratio? 1 is to 1. So the empirical formula is nothing but CH. Simple, isn't it? So what are we doing? We are not doing the lengthy method. We are simply finding the ratio, that is the given percentage by the atomic mass. Okay, we are finding the ratio of the number of moles straight away. So with this we can find the empirical formula easily. So what is the empirical mass of CH? C and H. So 12 plus 1, 13. So we have to find N again. So the next method is the same. Okay, so 26 by 13 gives us 2. Easy. So molecular formula is 2 into CH. So C2H2. So this is the answer. So do you find this much more easier than the first method? So I recommend you to practice the first sum which I gave you based on the short trick which I gave you now. So practice more questions to improve your speed. So now we move on to the next topic, which is stoichiometric calculation. Okay, what is the meaning of the word stoichiometry? The word stoichiometry means calculation of masses or volumes of the reactants and products involved in the chemical reaction. Okay, the first step is to balance that chemical equation. So this becomes crucial. So balancing a chemical reaction is according to law of conservation of mass. So recollect what is law of conservation of mass. Okay, so I will give you an example, that is the manufacturing of ammonia, that is Haber's process from N2 and H2. So N2 plus H2 gives us NH3 ammonia. So you have to balance this equation. So you find that there is N2, 2N in the reactant side. So you put a 2 in the products. So the number of hydrogen becomes 6 here. So to balance that, you need to add 3 as a stoichiometric coefficient in the left hand side. Okay, so from this equation we can conclude many things. From the balanced equation we can conclude many things. We can find out the number of moles, the volume, the molecules and the mass. So moles, from the balanced equation we find that 1 mole of nitrogen is reacting with 3 moles of hydrogen to give us 2 moles of ammonia. Similarly, volume, since all of these are gases, at STP we can conclude that there is 1 into 22.4 liters of nitrogen combining with 3 into 22.4 liters of hydrogen to yield 2 into 22.4 liters of ammonia. Alright, now talking about molecules. So 1 Na combines of nitrogen combines with 3 Na of hydrogen, giving us 2 Na molecules of ammonia. Then talking about mass, we find that 28 grams of nitrogen combines with just 6 grams of hydrogen to yield 34 grams of ammonia. 2 into 17. 17 is the molecular mass of ammonia, which gives us 34 grams. So what is stoichiometry? Basically it's nothing but the calculation of masses, volume, okay, number of molecules and everything of the reactants and products involved in a chemical reaction. Okay, so shall we see our question? So here in physical chemistry you have to be very familiar with the different models of questions. That's why whenever I explain something, I'm immediately taking up a question so that it doesn't become very theoretical. It needs to fit in the name physical chemistry. So we move on to the question, which reads as C5H12. What is this? It is pentane. On combustion produces carbon dioxide. Carbon dioxide on reduction with coke produces 5 liters of carbon monoxide. How many liters of alkane is taken initially? So they are asking us to find the volume of the reactant. So we know this is a question from stoichiometry. So we have to approach in that same manner. Okay, so C5H12, as I told you, is resembles the formula CnH2n plus 2, that is the general formula of alkane, which is the pentane. Okay, and this is undergoing the process of combustion. So any alkane or any hydrocarbon for that matter, and combined with oxygen, gives us carbon dioxide and water as the products, fixed products. Okay, so how do we balance? Try to balance on your own. You learnt balancing the equation in class 9 and 10 itself. So okay, so I'm not repeating how to balance. Okay, C5H12 plus 8O2 gives us 5 CO2 plus 6 H2O. Okay, so this is the first step. Next they are saying CO2 on reduction with coke. Okay, so CO2 is undergoing reduction with coke. Coke is nothing but carbon. So CO2 plus C gives us carbon monoxide, 5 liters of carbon monoxide. So balance this, CO2 plus C gives us CO. Balance this equation. So we get 2 CO2 plus C gives us 2 CO. Okay. In the question they have given us 5 liters of CO. So what should we do? We should make sure that the stoichiometric coefficient of carbon monoxide is 5. Okay. So for that, first we divide the equation by 2 to get CO2 plus half CO2, half C giving CO, and then we can multiply by 5, which gives us 5 CO2 plus 5 by 2 C giving 5 CO. So we have got this 5 CO, which is given in the question. So we can take this as 5 liters of CO. So here what we need to make sure is that this 5 CO2 in the reactant side in the second equation should correspond to the number of molecules, that is 5 CO2, present in the right hand side, the product side in the first equation, because from the CO2 which is released in the first step, we are using this CO2 for the reduction with coke, and then we are producing carbon monoxide. So always make sure that the product, that is CO2 in the product side in the first equation and the CO2 in the reactant side in the second equation are equal, that is the number of molecules are equal. So to produce 5 liters of CO, we have one, can you see, one molecule, we took only 1 liter of C5H12, that is pentane. We took 1 liter of pentane initially. So 1 liter is the answer. So I hope you have understood. Okay, the application, the important application of stoichiometric calculation is a topic called limiting reagent. Okay, in any reaction, chemical reaction, the reactants and different reactants may not be always of the same amount or of the required amount. one reactant will be of excess and the other reactant might be in lesser quantity. Okay, so that reactant which is present in the least amount, okay, that is least or limiting, okay, we say that which gets consumed fully, okay, so that reagent is called the limiting reagent because it limits the reagent, because after it gets consumed fully, because it's present in a very less quantity compared to the other reactant, so it's present in the least amount and gets consumed after some time. So after that the reaction does not take place, whatever amount the other reactant is present, however high amount the other reactant is present, so the entire reaction depends on this reactant which is present in the minute quantity, limiting quantity, least quantity. So after that the reaction does not take place. So this limits the amount of product formed. So the name limiting reagent. So reagent is nothing but reactant. So I hope you understood the meaning of limiting reagent. Limiting because it limits the product form, it limits the reaction, and reagent because limiting reagent is always a reactant and not a product. So reagent itself, the word reagent itself means it is a reactant. Okay, so let's consider the formation of water, okay, from hydrogen and oxygen. So 2H2 plus O2 gives us 2H2, a famous reaction which we all know. So the original ratio of hydrogen and oxygen is 2:1. The stoichiometric coefficient we can say is 2:1, which means that we can conclude that we need 2 moles of hydrogen and which combines with 1 mole of oxygen forming water. Okay, but in the reaction in the lab, for example, we are having 4 moles of hydrogen, okay, and 1 mole of oxygen is taken as reactants. Okay, we find that we require only 2 moles of hydrogen, but we have with us 4 moles of hydrogen, so which means hydrogen is the excess reagent, and oxygen on the other hand, we need oxygen is the limiting reagent. Here we can define the excess reagent, because excess reagent is that reagent which is present more than required, so some amount will be left unreacted, whereas the limiting reagent is completely consumed at the end of in the reaction, so nothing will be left. Okay, so I will give you a question in which you have to identify the limiting reagent. Okay, so we have this reaction A plus B2 gives us AB2. The first question goes as 300 atoms of A plus 200 molecules of B. This is the original setup. Okay, the number of molecules or atoms which is taken initially according to the chemical experiment that we are performing. So based on this you need to find out which one is the limiting reagent. So 300 atoms of A plus 100 B2. Okay, so we can write the reaction as 300 A plus 100 B2 because it's nothing but molecules of B. Okay, which means it's not B2. Be very careful. 200 molecules of B. So which means 100 B2. Okay, so in the question we find that the ratio of A and B2 is 1:1. A and B2 is 1:1. So from the first subdivision question we find that 300A is to 100, which gives us 3:1 as the ratio. So clearly B2 is the limiting reagent. Next, subdivision B. They have given us that 2 moles of A is combining with 3 moles of B. So then what is the ratio of A is to B2? It is 2:3. Here we can take as A is to B ratio itself. Okay, because they have given us 3 moles of B. So 2:3. So look at the first reaction which is given the start of the question, that is A plus B2 gives us AB2. What is the ratio of just A is to B? It is 1:2. Understood? So this is the confusing part. So listen carefully. We are taking the ratio of, so in the first step we wrote the ratio as 1:1. So here we got the ratio as 2:3. So we have to simplify. So for that, 2 into 1 by 2 is to 3 into 1 by 2. We are multiplying 1 by 2 on both the sides. So the 2 will get cancelled, leaves us with 1:1.5. So compare 1:1 and 1:1.5. So there's 1 present and 1.5 present. Oh, that is B. So which is more than the required. So B is the excess reagent and A is the limiting reagent. Okay, now let's move on to the next subdivision. 100 atoms of A plus 100 molecules of B. So 100A plus 50B2 gives us 100 molecules of B. So 50B2, because 50 into 2 gives us 100. So again here you find that the ratio is 1:1 ratio. We are taking the ratio of A is to B. So even the starting question, the ratio is 1:1. Here also the ratio is 1:1. So this means that there is no limiting reagent in this particular setup. Next we move on to the next subdivision. D. 2.5 mole of A plus 5 moles of B is taken. Okay. So what is the ratio? 2.5 is to 5, which is 1 by 2 is to 2, 1 is to 2. So compare the ratio 1:2 and the original ratio 1:1. So here 1 and here there is 2. So 2 is that is B is the excess reagent and A is the limiting reagent. Simple. I hope with this one example you would have clearly understood the meaning of limiting reagent. So the reagent which is present in the least amount, which limits the amount of product formed, which gets consumed fully in the reaction, is known as the limiting reagent. Okay, now let's move on to the next question. 3 grams of hydrogen reacts with 29 grams of oxygen to yield water. What amount of excess reagent will remain unreacted? Now this is an important model of question that is asked. Okay, so there are 3 steps. First step is to write the balanced chemical equation. Second step is to find the limiting reagent. And third step is to find that reactant which is consumed or left. So let's begin. First step, writing the balanced chemical equation. 2H2 plus O2 gives 2H2O. Okay, now we have to find the limiting reagent. So from the balanced reaction itself, we can conclude that 4 grams of H2 combines with 32 grams of O2 to yield 36 grams of water. So 4 grams of H2 combines with 32 grams of oxygen. So in the reaction, then in the question they have given that 3 grams of hydrogen is reacting. So let's find out the amount of oxygen required for 3 grams of hydrogen. On cross multiplication, we get 4x is equal to 32 into 3, giving x is equal to 24 grams. But in the question, we have 29 grams of oxygen with us, which clearly indicates that oxygen is the excess reagent and hydrogen is the limiting reagent. So the mass of oxygen that gets consumed is 24 grams of oxygen is consumed. So how much of oxygen is left unreacted? 29 minus 24, 5 grams of oxygen is unreacted. So this is our answer. So now let's look at the next question. When 11.2 liters of hydrogen reacts with 22.4 liters of chlorine, what is the limiting reagent? Second question, how much of the excess reagent is left? Okay, so the first step is to write the chemical equation, balanced chemical equation, which is H2 plus Cl2 gives us 2HCl. Okay, now I will tell you a trick to find out the limiting reagent within a very less time. So the trick is to compare this ratio, the number of moles divided by the stoichiometric coefficient. So let's apply this trick over here. So they have given 11.2 liters of hydrogen. From this we can find the number of moles of hydrogen, 11.2 by 22.4 liters, given volume by 22.4 liters, by the stoichiometric coefficient of the balanced chemical reaction, which is simply 1. So similarly for chlorine, again 22.4 liters by 22.4 liters by the stoichiometric coefficient, which is 1, which gives us 1. So clearly this 1 by 2 is less than 1. So H2 becomes the limiting reagent. So whichever ratio is less, we have to compare the ratio of the reactants, and whosever ratio is less, that becomes the limiting reagent. So chlorine is the excess reagent. So we need to find in the second subdivision the amount of excess reagent which is left unreacted. So simply equate this 1 by 2, which is equal to x. Let's say x amount of chlorine, x liters of chlorine reacts in the reaction by 22.4 liters by the stoichiometric coefficient, which is 1. So we get half is equal to x by 22.4 liters, and x is equal to 11.2 liters. So this x is nothing but the amount of chlorine, the volume of chlorine that gets consumed in the reaction. So how much of chlorine is left? 22.4 liters minus this x, which gives us 11.2 liters. So this is the answer for the second subdivision. So now I'll give you another question. Pause the video and try to do it on your own and check if your answer matches with mine. The question is, they've given the balanced equation. 4Fe plus 3O2 gives 2Fe2O3. 4.8 grams of oxygen is used to burn 0.15 mole of iron. Find the limiting reagent and the mass of the reactant left over. So our first step is writing the balanced chemical equation. It is already given in the question, so the job is easier. Okay, so our first job here in this question is to find the limiting reagent. So what do? According to the short trick which I told you in the previous question, yes, we need to compare the ratio of number of moles divided by stoichiometric coefficient of both the reactants. So number of moles they've given 0.15 moles of Fe divided by 4, which is the stoichiometric coefficient. Similarly, they have given 4.8 grams of oxygen. So given mass by molecular mass gives us the number of moles. So 4.8 by 32 divided by 3, which is the stoichiometric coefficient. So now do you notice that everywhere in small places we are using the mole concept here? That's why I told you that mole concept is very important for all aspects. Okay. So now our job is to simplify and compare the ratio. So on simplifying this ratio for Fe, we get 3 by 80. Similarly, for O2, we get 1 by 20. So making the denominators same, we multiply by 4 to get 4 by 80. So obviously 3 by 80 is less than 4 by 80. So Fe is the limiting reagent. So we have found out the limiting reagent, that is Fe. That's the answer for the first part of the question. Second part of the question, we are required to find the mass of the reactant which is left over. So what should we do? We should equate 3 by 80 to x by 32 into 3. That is, x here represents the amount of oxygen which is consumed in the reaction, that is the given mass by molecular mass 32. Okay, because the O2 divided by the stoichiometric coefficient, which is 3. So that's why I've written 32 into 3. So okay, so on simplifying, we get x is equal to 3 into 3 into 32 by 80. On solving, what do we get? We get x as 3.6. So in the question they have given 4.8 grams of oxygen is used to burn. Okay, so but only 3.6 grams of oxygen is consumed in the reaction. So how much is left? 4.8 minus 3.6, which is 1.2 grams of oxygen is left over at the end of the reaction. So this is the answer for the next part of the question. Now I am extending the question as also find the mass of Fe2O3 formed. Now what will you do? So for any questions based on this, we always take the ratio of the limiting reagent, the ratio we obtained, that is 3 by 80, and we equate it to the whatever quantity is being asked. Like how we found out the mass of oxygen consumed, similarly we can find the mass of product which is being formed. So we can equate this 3 by 80 is equal to x. Here this x represents the mass of Fe2O3 formed by same thing, molecular mass, that is we are finding the number of moles divided by the stoichiometric coefficient. So x by 2 times 56, molecular mass, atomic mass of iron is 56, plus 48 Fe2O3, so 3 into 16 is 48, by the stoichiometric coefficient, which is 2. So simplify, cancel, you can cancel the 2. So 3 by 20 is equal to x by 56 plus 12. So what do we get? We get x as 12 grams. So this 12 represents the mass of the product being formed. Okay, so 12 grams of Fe2O3 is produced. This is the answer. So this completes the major chunk of the chapter. So in my next lecture, I will be discussing the concentration term, which is extremely important, which also repeats in the chapter called Solutions of grade 12, and we will be talking about additional topics like normality, equivalence, okay, gram equivalence, and all that, law of chemical equivalence, combination, and all that. We will be discussing that in the next topic with many problems. So stay tuned for more videos. Thank you.